Suppose we have two vectors A and B. Can you tell me if we can add these vectors? What does it even mean to add two vectors? To understand this, let's first look at addition of scalars first. Suppose we have two rods with their respective lengths and mass as this. Can you tell me what will be the sum of the lengths of the two rods? It's easy, right? It will be 3 meters. But now, what if I ask you to add the length of the first rod with the mass of the second rod? Does it make sense? No, right? We know that to add two scalars, they should have the same unit. That is, they should represent the same physical quantity. We can add length with another length only and mass with another mass only, but not a length with a mass. Similarly, to understand what does the addition of two vectors mean, we will have to look at the vector quantity they represent. Let's consider displacement vectors. Suppose we're at this point P and we move to this point Q. We know that this displacement will be given by the vector PQ. Now suppose from point Q we move to the point R here, then this displacement will be given by the vector QR. Now can you tell me what will our net displacement be? Right, it will be from P to R. The net effect of our displacement, first from P to Q and then from Q to R, is equal to the displacement from P to R. And this net displacement will be given by the vector PR. So we can say that the vector sum of these two displacement vectors, PQ and QR, is equal to the displacement vector PR. Now, did you notice these three vectors form a triangle PQR? Yes, the two sides of the triangle PQ and QR represent these two vectors, both in magnitude and direction, which are taken in the same order. That is, from P to Q and then from Q to R. Now, we take the third side of the triangle. Here, instead of taking it in the same order, that is from R to P, we take it in the opposite order, P to R. Then the resultant vector PR will represent the vector sum of the two vectors, both in magnitude and direction. This is known as the triangle law of vector addition. Take a moment and have a look at this. Now, by applying this law, we can add any two vectors. Suppose we have to add these two vectors A and B. So for this, first we need to position the two vectors such that the initial point of one vector coincides with the terminal point of the other vector. So, we move the vector B parallel to its position without changing its magnitude and direction, and place it such that the initial point of vector B coincides with the terminal point of vector A. Now notice that these 3 points A, B and C form a triangle. So according to the triangle law of vector addition, the vector sum of these two vectors will be the third side of the triangle ABC, such that its initial point and that of vector A coincide, and its terminal point and that of vector B coincide. We write it as this. So in this way, by applying the triangle law of vector addition, we can find the vector sum of two vectors. Here we can find the magnitude and the direction of the vector AC by using geometric properties of the triangle ABC. But it's a little difficult. Hence, we will see another easier method for this in our upcoming videos. Here, we just need to understand what does the addition of vectors mean intuitively. Now suppose instead of two vectors, we want to add these four vectors. What will the vector sum be? Can you apply this law here? Right, it will be this vector whose initial point will be the initial point of vector A and its terminal point will be the terminal point of the vector D. How is that?
क्लियर बेटे, ये जो वीडियो है उसका मेन मैटर यही था कि जितनी भी साइड हैं ए वेक्टर, बी वेक्टर, सी वेक्टर, हम इन चारों को या इन तीनों को जब भी हम अगर ट्रायंगल की बात आती है, तीनों को सम अगर हम कर दें तो वो ए बी और सी जो है ए बी प्लस बी सी किसके इक्वल हो जाएगा ए सी। जैसे हम पाइथागोरस में वो हम स्क्वायर लगाते थे, ये हम वेक्टर की फॉर्मेशन में ले रहे हैं। ये ट्रायंगल लॉ ऑफ वेक्टर एडिशन है। आगे मैं आपको पैरेललोग्राम का वेक्टर एडिशन भी बताऊंगी। जो हमने पैरेललोग्राम जिसकी दोनों साइड स्क्वायर जैसी होती हैं, उनकी अपोजिट साइड पैरेलल होती हैं एक दूसरे के, उनके भी आपको ये ट्रायंगल लॉ ऑफ वेक्टर एडिशन एंड पैरेललोग्राम ऑफ वेक्टर, ये मोस्ट इम्पॉर्टेंट इक्वेशन है हमारे वेक्टर वाले चैप्टर में। क्लियर?
So, suppose first we add these two vectors A and B, then we will get this vector E. Then we add this vector E with the third vector C to get this vector F. Now finally adding this vector F with the fourth one D will give us this vector R.
सी, इन्होंने एक क्वाड्रिलेटर को भी ट्रायंगल के फॉर्म में, जैसे ए और बी को इन्होंने कंबाइन किया तो ई वेक्टर लगा दिया। फिर उन्होंने क्या किया, एक लास्ट वाले वेक्टर से सी और डी को कंबाइन किया तो एफ वेक्टर लगा दिया। ठीक है, फिर उन्होंने क्या किया, लास्ट में उसी पॉइंट से दूसरे पर जाएंगे और तीनों को ऐड ऑन कर देंगे तो आर वेक्टर लगाएंगे। इट मीन्स रिजल्टेंट वेक्टर इन सबको ऐड ऑन करने वाला।
If we think of these vectors as the displacement vectors, then it's easy to see that this vector R will be the final resultant vector of these four vectors. So, we saw here how we can add two vectors using the triangle law. This law is easily understood if we think of the vectors as displacement vectors. Now, instead of this, if we think of the vectors as velocity vectors, we arrive at another law of vector addition called the parallelogram law of vector addition. We will see this law in the next lesson.